oscillations per second. Heart pumps the blood to the different body organs.
Both statements are in true. It is always true.
My dear Tswreis, before going to the topic, I will ask some questions. Okay, are you ready? Yes, very good. How the molecules are formed? Yes, the molecules are formed by some bonds. So, what is a bond? Yes, correct, binding two orbitals or molecules. Which type of bonds known to us? Yes, covalent, ionic, coordinate covalent, hydrogen bonds. These bonds are commonly called as chemical bonds. Okay friends, understood? These bonds are commonly called as chemical bonds. In these chemical bonds, covalent bond is formed by some orbitals. Did you understand? In this chemical bond, covalent bond is formed by some orbitals. So, what are they? Yes, they are S, P and D orbitals. Which orbitals? S, P and D orbitals. Okay. So, in these Sp3 hybrid orbitals, important role play in hybridization. Okay. Sp3 orbitals play important role in hybridization. Okay friends, now we are discuss about hybridization. Which topic is discussing to now? Yes, hybridization. Okay friends, what is mean by hybridization? The process of intermixing atomic orbitals almost equal energy and they distribute into equal number of new types of hybrid orbitals. Did you understood? The process of intermixing atomic orbitals almost equal energy and they distribute into in equal number of new types of hybrid orbitals. This phenomenon known as hybridization. In this hybridization, Sp3 orbitals play important role. Is it correct? Yes. So, these orbitals have specific shapes. The S orbital is spherical in shape and P orbital is dumbbell in shape and D orbital is double dumbbell in shape. Okay, understood? It is the shapes of orbitals. And next, so friends, why these molecules are hybridized? Let us see the help of the slide. Just looking at valence electrons. First one is beryllium. Beryllium atomic number 4. So, electron configuration 1s2, 2s2. It does not have valence electrons. Okay. Beryllium should form no covalent bonds. And next one is boron. Boron atomic number 5. So, electron configuration is 1s2, 2s2, 2p1. It has one valence electron. Okay. So, boron should form one covalent bond. And last one is carbon. Carbon atomic number 6. Electron configuration is 1s2, 2s2, 2p2. It has two valence electrons. So, carbon should form two covalent bonds. But beryllium form beryllium chloride. boron form boron trichloride and carbon form methane. So, why the hybrid orbitals are formed? Let us see that. To explain the bonding in molecules like beryllium chloride, boron trichloride and methane, Linus Pauling proposed that orbitals become hybridized. Next one is hybrid orbitals are orbitals created by mixing the s, p and d orbitals of an atom. Which rules followed by in this hybridization? Let us see that also. The number of hybrid orbitals is always equal to the number of atomic orbitals that are combined to make the hybrid set. And next one is hybrid orbital sets are always built by combining an s orbital with as many p or d orbitals necessary to accommodate the bonding and lone pairs on the central atom. And next one is the hybrid orbitals are directed towards the terminal atoms. These results in a better orbital overlap and stronger bonds between the central and terminal atoms. Okay friends, did you understood? Okay. Now we are discuss various types of hybridizations. Okay. They are Sp hybridization. In this hybridization, one s orbital, one p orbitals presenting. The shape of the molecule is linear. Examples are Sp hybridization, beryllium chloride, boron trifluoride. Okay. Next one is Sp2 hybridization. In this hybridization, one s orbital and two p orbitals participated. Shape of the molecule trigonal planar. Examples are Sp2 hybridization, boron trichloride, boron trifluoride. And next hybridization Sp3 hybridization. In this hybridization, one s orbital and three p orbitals participated. Shape of the molecule tetrahedral. Examples are Sp3 hybridization, methane, carbon tetrachloride. And next one is Sp3d hybridization. In this hybridization, one s orbital, three p orbitals and one d orbital participated. Shape of the molecule trigonal by pyramidal. Examples are Sp3d. Phosphorus trifluoride, phosphorus pentachloride. And next one is Sp3d2 hybridization. In this hybridization, one s orbital, three p orbitals and two d orbitals participating. Shape of the molecules is squirrel pyramidal. Examples are Sp3d2 hybridization, bromine pentafluoride. And next one is Sp2 hybridization. In this hybridization, one s orbital, two p orbitals, one d orbitals participated. Shape of the molecule square planar. Okay. Examples are Sp2 hybridization, tetracyanonickel, and next one is tetrachloroplatinum. Next hybridization is D2sp3 hybridization. In this hybridization, one s orbital, three p orbitals and two d orbitals participated. Shape of the molecule octahedral. Examples are D2sp3 hybridization, sulfur hexafluoride, and next one chromium hexafluoride, and next example is triaminocyan. Okay. Now we are discuss Sp hybridization. Sp hybridization. In this hybridization, one s orbital, one p orbitals intermix with each other. It gives two sp hybrid orbitals. In this hybridization, how many s orbitals present in here? One s orbital. How many p orbitals present in here? One orbital. One s orbital, one p orbital. Intermix with each other, it gives two sp hybrid orbitals. Okay, my dear sparrows, understood? Okay, very good. In these hybrid orbitals, s character is 50%, p character is 50%. Okay, next examples of sp hybridization. Beryllium chloride, beryllium hydride, beryllium fluoride, and etc. Let us take one example in this. Okay, beryllium chloride. In this BeCl2, central atom is S, correct, beryllium. Atomic number of beryllium is S, exactly correct, 4. So, electron configuration is central atom beryllium, atomic number is 4. Electron configuration is 1s2, 2s2. It is in ground state electron configuration. Okay, understood? When it is in excited state, electron configuration is 1s2, 2s1, 2p1x. It is in excited state electron configuration. When it is in excited state, electrons moves from s orbitals to p orbitals. These sp orbitals intermix with each other, it gives two sp hybrid orbitals. Okay, these sp hybrid orbitals overlap with the other elements. Okay, did you understood? Okay, and structure of the beryllium chloride. Sp hybrid orbitals of beryllium overlap with the p orbitals of chlorine atoms. Okay, and it forms two sigma bonds, 1, 2. How many sigma bonds? 2. Structure of the beryllium chloride. Next, bond angle is 180 degrees. It is bond angle 180 degrees. Okay. Structure, shape is linear. Did you understood? Okay. Let us see, we easily understand with the help of the one slide. Sp hybrid orbitals. Beryllium electron configuration is 1s2, 2s2. So, in these orbitals, electrons moves from s orbitals to p orbitals. After promotion, excited state electron configuration is 1s2, 2s1, 2p1. When it is in excited state, electrons moves from s orbitals to p orbitals. So, these s and p orbitals intermix with each other, it gives two sp hybrid orbitals on beryllium. These two p orbitals unhybridized, and next the s orbital combined with p orbital and it form sp hybrid orbitals lie in x axis, and these two p orbitals unhybridized. Let us see what is going on in this hybridization process. Central atom carbon, carbon atomic number 6, electron configuration 1s2, 2s2, 2p2. Let us see what will happen. These blue color sphericals indicate 1s orbital. Okay. This orange color indicates spherical shape in 2s orbitals. Next, pink and yellow colors, dumbbell shape indicates 2 p orbitals. Okay. These electrons promote from s orbitals to p orbitals. These sp orbitals intermix with each other. It gives 2 sp hybrid orbitals. This is 2 sp hybrid orbitals. Next, sp hybridized. It is sp hybridization. Shape is linear. Okay. Now we are easily understand with the help of the balloons. Let us see it. It is the central atom. These two are terminal atoms. Okay. This is the sp hybrid orbitals of beryllium. It is the p orbitals of chlorine atoms. These sp hybrid orbitals of beryllium overlap with the p orbitals of chlorine atoms. Bond angle is 180 degrees and shape is linear. It is central atom. Sp hybrid orbitals is there. So, characteristic of S equal to 50% and P equal to 50%. My dear Tswreis, did you understood? Okay, very good. Next, shall we go through another hybridization? Next one is Sp2 hybridization. Sp2 hybridization. In this hybridization, one s orbital, 2 p orbitals intermix with each other. It gives 3 sp2 hybrid orbitals. How many s orbitals present in here? 1. How many p orbitals? 2. One s orbital, 2 p orbitals intermix with each other. It gives 3 sp2 hybrid orbitals. Okay friends. Next, in this sp2 hybrid orbitals, s character is about 33%. P character is about 67%. Okay. Next, examples of sp2 hybridization. Boron trichloride, boron trifluoride and etc. Okay. Did you understood? Next, let us take one example in this. How many examples? One example, etc. We can take one example, BCl3. In this BCl3, central atom is boron. Atomic number of boron is 5. So, ground state electron configuration is 1s2, 2s2, 2p1. It is in ground state electron configuration. When it is in excited state, electron configuration is 1s2, 2s1, 2p1x, 2p1y. It is in excited state electron configuration. Okay. These sp orbitals promote with each other. It gives 3 sp2 hybrid orbitals. How many sp2 hybrid orbitals? 3. When it is in excited state, electrons moves from s orbitals to p orbitals. Okay, next structure of the boron chloride. sp hybrid orbitals of boron overlap with the p orbitals of chlorine atoms and form 3 sigma bonds, 1, 2, 3. How many sigma bonds? 3 sigma bonds. Okay. Next, bond angle is 120 degrees. Shape is trigonal planar. Okay, did you understood? Sp hybrid orbitals of boron overlap with the p orbitals of chlorine atoms and it form 3 sigma bonds. Okay, bond angle is 120 degrees, shape is trigonal planar. Let us see, we easily understand with the help of the slide. Sp2 hybrid orbitals. Atomic number of boron is 5. So, electron configuration 1s2, 2s1, 2s2, 2p1. Electrons promotes from s orbitals to p orbitals. After promotion, excited state electron configuration is 1s2, 2s1, 2p1x, 2p1y. When it is in excited state, electrons moves from s orbitals to p orbitals and these s and p orbitals intermix with each other. It gives 3 sp2 hybrid orbitals of boron. One p orbital is unhybridized and next the s orbital and px py orbitals overlap with each other and it form 3 sp2 hybrid orbitals in x and y axis. Okay. Another one is unhybridized. Let us see what going on sp2 hybridization. Boron electron configuration is 1s2, 2s2, 2p1. When it is in excited state, electrons moves from s orbitals to p orbitals. So, it gives 3 sp2 hybrid orbitals, one is unhybridized. The 3 hybrid orbitals are made from 1 s orbital and 2 p orbitals. It gives 3 sp2 hybrids. Okay, 3 electron pairs. Shape is trigonal planar. Bond angle is 120 degrees. Now we have 3 half-filled hybrid orbitals that can be used to form boron fluorine sigma bonds. And orbitals from each fluorine overlap one of the sp2 hybrids to form boron fluorine sigma bond. This green color indicates sigma bond. This is electrons promote from s orbitals to p orbitals. The 2s and 3s p orbitals of the boron atom, 2s and 3 p orbitals. Okay, next hybridization produce 3 new orbitals. The sp2 hybrid orbitals all having the same energy. Okay, next in this hybridization process, blue color sparkling indicates 1s orbital, orange color spherical indicates 2s orbitals, pink and yellow dumbbell shape indicates p orbitals. These sp orbitals intermix with each other and electrons promote from s orbitals to p orbitals. Next, s and p orbitals intermix with each other. It gives 3 sp2 hybrid orbitals. It is 3 sp2 hybrid orbitals. Sp2 hybridization. Bond angle is 120 degrees. Trigonal planar shape. Okay. Next, we shall go through another hybridization. Next one is Sp3 hybridization. Friends, I am explaining about this model. It is Sp2 Hybridization Model. It is the central atom. These three are terminal atoms. Okay. This is Sp hybrid orbitals of boron. It is p orbitals of chlorine atoms. These central atom of Sp hybrid orbitals of boron overlap with the p orbitals of chlorine atoms. Okay. Bond angle is 120 degrees. Shape is trigonal planar. This s orbital character is 33%, p orbital character is 67%. It is Sp2 hybridization model. Did you understood? Next, discuss about Sp3 hybridization. In this hybridization, one s orbital, 3 p orbitals intermix with each other. It gives 4 Sp3 hybrid orbitals. Okay. How many s orbitals? 1. 3 p orbitals. Intermix with each other, it gives 4 Sp3 hybrid orbitals. Okay. Next, examples of Sp3 hybridization. Carbon tetrachloride, CH4 and etc. Let us take one example in this. Methane. In CH4, central atom is carbon. Atomic number of carbon is 6. So, ground state electron configuration is 1s2, 2s2, 2p2. Okay, it is in ground state electron configuration. Did you understood? In this hybridization, one s orbital, 3 p orbitals intermix with each other. It gives 4 Sp3 hybrid orbitals. Examples of Sp3 hybridization: carbon tetrachloride, methane. Let us take one example in this methane. In this CH4, central atom is carbon. Carbon atomic number is 6. So, ground state electron configuration 1s2, 2s2, 2p2. It is in ground state electron configuration. Next, when it is in excited state, electron configuration is 1s2, 2s1, 2p1x, 2p1y, 2p1z. Okay? It is in excited state electron configuration. Okay? When it is in excited state, electrons promotes from s orbitals to p orbitals. These sp orbitals intermix with each other. It gives 4 sp3 hybrid orbitals.